Hi everyone, welcome to session 4L. Git Native Development is here. Now what? With Anthony Anta. Anthony has asked if you've got any questions, please put them in the chat and he'll address them at the end of the session. It shouldn't be too tight to the whole hour, so there'll be plenty of opportunity to get those questions answered at the end of the session. So I'll now hand it over to you, Anthony.
Thank you, Stuart. Appreciate it. Thanks everybody for coming to this session. As Stuart already announced, the title of this session is Git Native Development is Here, Now What? As you can see by the picture, the gray hair and wrinkles and all that is true. That's not a doctored picture at all. So let's go ahead and jump right into it, right? So first, let me give you a little background on me, so you know I'm not just another piece of eye candy that they threw out here to do a talk. So before I worked, right now I'm a DevOps architect for BMC Software. Before that, from about 2014 to 2021, I was the director of engineering for CI/CD at American Express. And as such, I had ownership and responsibility for the design, development, operations of our entire DevOps platform. That included primarily on the distributed side, but also included the mainframe and the mainframe platform. In 2018, I was given the task to bring DevOps onto the mainframe, at which point I partnered with BMC Software and implemented an entire agile platform that basically allowed for DevOps on the mainframe, automation on the mainframe, reusing all of the capabilities and things that were already there and allowed for those pipelines and automation onto the mainframe platform. The scope of this project at the time was 500 applications and 3,500 engineers that we migrated onto a DevOps platform, and we automated pipelines from dev to production. So basically, we were able to take what we had done on the distributed side and probably reuse 70–80% of it and just hook it into the mainframe and allow the pipelines to handle the nuances of the mainframe platform, but the look and feel and operation and everything of moving source code from dev to production was the same. So during that time, as part of my just general ownership of DevOps and the DevOps platform, we also ran Git, at least Git for the distributed side. And we started out with Bitbucket, and then we moved our Git platform from Bitbucket onto GitHub Enterprise, which is the on-prem offering of GitHub. So from there, let's go ahead and move on. So now that I don't think anyone on this call would argue that DevOps is there on the mainframe platform. I think that was a talk 3, 4, 5 years ago. I think every organization here is practicing some form of DevOps or attempting to practice some form of DevOps or has a plan for transformation and automation on the mainframe. So I think that boat has sailed. But what I'm hearing a lot in the industry and in the field is a lot of companies looking to move to Git, looking to move onto a Git platform for their mainframe source code management. So the first thing I wanted to address is Git on the mainframe, right? Like, what is it and what is it not? Because I think that there are a lot of thoughts, and I think that there are a lot of capabilities that are on the mainframe that Git, excuse me, people using Git on the mainframe that people are, I think there's a lot of misconceptions. Sorry, I'm getting a little tongue-tied there. There are a lot of misconceptions about what Git is and what Git is not. So first, what it is, right? It's a very highly adopted source code management system. I will argue and probably provide you statistics to back it up that it is the most adopted source code management system in the world. If you are at a company of any size, industry, shape, you are running Git of some kind, probably 90+% easily. All of your distributed code is probably being versioned and handled through Git. And at that point, your company is already using Git. It is very fast and efficient, and it is designed to handle very large projects with ease and actually utilize little memory and little CPU. So under the hood, Git was designed by Linus Torvalds, the guy who created Linux, and as a way to allow him to collaborate with his team better. And it's designed at its core to be very efficient, very, very efficient on your system. It's very easy to use with intuitive GUIs and command line interfaces. Now, if you're coming from a mainframe world onto Git, a lot of it seems different because you're not used to using it. But once you understand Git and how it works, the GUIs will walk you through most anything, and it has a very rich and robust command line interface to allow you to be able to do anything. Once you understand Git nomenclature and the nuances of how you use Git, then at that point, actually using it is very easy. It's built for collaboration, right? It's built for collaboration and to work with large teams, small teams, medium-sized teams, one size fits all. And one of the things that I hear a lot from mainframe teams as well, permissions, the mainframe is secure, the mainframe. Any Git client that I've ever worked with has a very robust RBAC model that allows for permission-based separation of duties and control over your source code. So you can, at a repository level, at a folder level, at almost any level, you can set permissions based on roles and allow for that separation of duties that you've gotten used to. So you can set it up in such a way that I can check in and check out, but I can't necessarily create release branches to push into production, right? So you have the ability to do those role-based permissions. That said, what is it? What is it not? Right? What it is not. For distributed source code only, Git does not have a preference of source code that is stored in Git. It can handle Go, Java, Node, Python, COBOL, assembler, copybooks, JCL, whatever you want to store inside of Git, you can store in Git from a source code point of view. Git does not have a preference or a thought around what kind of source code you're using or what you're deploying, what your platform you're deploying to, right? So there is the idea that Git is only for your distributed side is just because as it stands, that is what your distributed guys are using, and your mainframe teams are using another probably mainframe based source code management system. But Git is neutral. It doesn't matter. A build capability. Git is not a build capability. So a lot of people conflate Git with other parts of a DevOps toolchain. And Git is for storing, versioning, and managing source code only. It will not build anything. If you are going to move your mainframe source to Git, you will have to have something on the mainframe to build it. In the same way that a team using Java has to have some kind of build capability built into Jenkins or another, somewhere to execute a Maven script. It's the same thing with COBOL. Git is only a source code management system. Now, some Git clients have capabilities built into them, and we'll get into this in a little bit, but GitHub with GitHub Actions has the ability to workflow and call certain things. Same thing with GitLab and even Bitbucket. But those are capabilities that are built into the client. They are not native to Git or the source code management side. And even then, they're calling something around like Maven or another tool to actually initiate the build. It is not a deployment capability. And this is also the same thing as above, right? It is not a deployment capability. It will store and version your source code and will allow you to check it in and check it out and even clone your code to another platform or another place, your local environment or elsewhere. But it will not deploy your source. It will not, you should not be storing binary artifacts in Git because that's a whole other can of worms that you shouldn't be going down. And number two, it is not there to deploy your code onto infrastructure. Can you make it do that? Maybe. Just like above, are there capabilities built into some tools or built into the client? Yes. But at the end of the day, it is not a deployment tool. You're going to have something external to Git to handle that and handle it better. It's also not a binary artifact management system. It's for storing source files and text files. It does not handle binary management very well. And you will find that it actually can cause issues when you put your binary artifacts into Git. Now, before somebody raises their hands or throws an angry question or comment into the chat, yes, people can have done it. People can do it. You can make it work. You can make anything work, right? I could hook a Ferrari up and use it to pull a plow, but that's not what it's designed to do. It doesn't handle binary artifacts well, and it doesn't. You're much better off going with a binary artifact management tool like JFrog or Nexus than you are storing that in Git, and it can actually cause a lot of problems in Git from a size of your repo point of view. But I'll get into that in a little bit. But that is what Git is, and that is what Git is not. It is a perfectly fine and actually very good tool to store your source code. And it doesn't matter whether your source is mainframe source or your source is cloud or your source is anything, any platform in between. Git is a wonderful tool for storing your source code, and it doesn't matter the platform. Well, one more thing I'll add before we get off of this, this particular slide as well. This is also what most engineering students in college, this is what they're using. The very first thing they do is they get some kind of GitHub repo, and they use that for their homework. So when you bring people in, when you look at that new generation that's going to be coming on to the mainframe platform, because like it or lump it, there's going to be new people that are going to be coming into the mainframe. They already know Git, and they already know Git like the back of their hand. They speak it natively. So I think it's not so much that there's anything against the source code managers on the mainframe, but I think it's inevitable that people are going to go where they're more comfortable. And I think the next generation is much more comfortable in Git than not. Again, controversial thing. Save questions or comments for the end. So what are some popular choices, right? So you've heard me mention Git clients, right? When you talk about Git clients, what you're really talking about, and I'm going to talk about the big three: Bitbucket, GitHub, and GitLab. There are other Git clients out there. They're probably fine, but when we talk about Git clients and what are Git clients, these are probably, again, 90+% of everybody has one of these three offerings, right? Even if you're using Azure DevOps, in the background, Azure DevOps is using GitHub. So ever since Microsoft bought GitHub, that's what Azure DevOps is using as far as their Git client that you get when you're using the Azure DevOps pipelines. And what are these Git clients? These are interfaces that are built around Git. At its core, Git is Git, right? It doesn't matter whether you're on Bitbucket, GitHub, or GitLab. The client is a wrapper around that provides you some functionality and some capabilities to sort of organize Git. Not organize, that's probably a bad way to put it, but it provides you a wrapper that is an interface onto the native command line Git. Each one of these has, command line interfaces. Each one of these is a very popular choice. And there are some subtle differences between them. But at the end of the day, well, let me back up. So first, let's talk Bitbucket. This is developed by Atlassian, and it provides all of your standard Git capabilities, right? It has an on-prem and hosted capability. The last I checked, I believe they were They were trying to move away from their on-prem and go more to a hosted model, but I don't know how successful they have or haven't been. And to be honest, I haven't checked up on that in a while, but they offer both as it stands right now. This is your pretty, this is a good vanilla Git client. This is, Bitbucket is perfectly fine. And I used Bitbucket for years, and it actually is a very good, very powerful tool. The real cool thing about Bitbucket, as far as if you're going to choose one, if you're starting from the ground up, number one, it's cheaper than the other two, but it comes as part of the Atlassian tool set. So where it really provides value is it natively integrates with Jira, Confluence, any of your other popular Atlassian tools. And Jira and Confluence are incredibly popular. This is the kind of integration where I can install Bitbucket and just point it at Jira, and it automatically syncs up with it. Same thing with Confluence. So I can automatically create a branch based off of a Jira ticket, and et cetera, et cetera, et cetera. So Bitbucket is very, like I said, it's a very solid tool, especially if you're using Jira and Confluence. GitHub. GitHub is by far the most popular Git client. A lot of times people almost synonymously talk about GitHub in the same vein that they talk about Git. It's sort of like a Kleenex. Even if you're not using a Kleenex brand tissue, you say, hand me a Kleenex. GitHub is a little bit the same way, right? This is the most popular Git client. Now, ask someone from Atlassian or ask someone from GitLab, you're going to get a little different answer, but I think the numbers bear the truth, right? And it houses the majority of the world's open source projects. By far, GitHub has, if you go out and you look at an open source project, it has a GitHub repo, a free GitHub repo behind it. GitHub, just like Bitbucket, also has an on-prem and a hosted offering. And their on-prem offering is actually just as robust as their hosted offering. Usually it's only about one release behind as far as new functionality. Very fast and efficient branching. GitHub is very fast, very efficient, very good at merging, and they have lots of additional tools built around Git and source code management. They have a lot of security tools, a lot of scanning tools, GitHub Actions that has come out and been out for about a year now, which is a pretty good orchestration tool. They have a lot of workflows. And the cool thing about GitHub is pretty much anything you've done, someone's probably already there doing it. A very, very, very robust community. And it's by far a very popular choice. GitHub is, like I said, very, very cool. The last one though is GitLab. So I make GitLab akin to the Swiss Army knife of Git clients. It merges Git capabilities with CI and CD pipelines and other functionality into a single tool. Very easy to use, very easy to install, very easy to set up. And this is fast becoming a popular choice. They are actually eating into GitHub and Bitbucket's user base. And all in all, it's actually a very good choice because it provides you the ability to do Git and a powerful Git offering, while at the same time giving you your pipeline and orchestration capabilities all built into one easy to use client. So now if I'm a team, I can create a GitHub repo and just immediately from that repo set up pipelines, set up everything that you need to do. And all three of these integrate with all of the popular tools. SonarQube integrates with all of them. Jira, while Bitbucket natively integrates with it, you can also use it with GitHub and GitLab. Same thing with Confluence. So all your popular DevOps tooling and DevOps capabilities are available through these tools. Does it matter which one you pick? No. Git is Git. Your choice of clients comes down to your preference, right? Which one of these fits your organizational objectives? most likely somewhere in your company, you're already using one of these clients. And if you do, then the ability to use them, again, this is probably, I'm going to get flamed in the chat at the end of this, but they're all pretty much the same. There are people, excuse me, that will fight holy wars over GitHub versus GitLab versus Bitbucket versus whatever. But at the end of the day, Git is Git. There's some slight nomenclature differences between, GitHub and GitLab. GitHub calls it a pull request. GitLab calls it a merge request, those kind of things. But those are nuances. So it really doesn't matter. You need, as an organization, as a team, as a person, need to pick which one of these will fit your needs best and pick it. And you're not going to be losing out one way or the other. So how do you use Git, right? So the big thing that I've seen is as people are going through and moving their source code onto Git, one of the biggest issues that I see is training. So how do I use Git? Okay, so I'm used to Endeavor, I'm used to ChangeMan, I'm used to CodePipeline or ISPW, I'm used to whatever homegrown system. This is how it works. This is how I get my code. This is how I check my code in. So how does Git work? Git was designed to be very open and be very easy to use. But over time, a lot of teams have come up with what they like to call methodologies, right? Different Git native development methodologies. First one is Gitflow. Arguably the most popular one. Depends on what article you read, what blog you talk to, what thing you do. But this was an original way, and I'm going to go into these in more detail once I introduce them. But one of the original most popular ways to handle branching and tagging and releasing of Git code. And it has its, like everything, it has its pros and cons. Trunk-based development. That's also an incredibly popular Git methodology. And depending on, again, what blog or article you read, this is the most popular one and the one that most people profess to use. The last one is GitHub Flow, excuse me. GitHub Flow is a simplification of GitFlow that the guys at GitHub came up with. It has a lot of the same capabilities or the same flow, quote unquote, flow as GitFlow, but it's simpler, not as many feature branches and tags used. But let's go into these in a little bit of detail so we could talk about, what the different pros and cons and how each one of these methodologies work. So the first one let's talk about is GitFlow, right? So GitFlow is a branching methodology and it focuses on two permanent branches, main and develop. Main is your copy of production. So whatever you're deploying into production eventually gets merged into main, and that always stays as your copy of production. And main is where you would do things like emergency releases from. Develop is the other permanent branch, and develop is the branch through which you branch feature branches, right? So a feature branch is, I have a feature that I'm working on. I'm going to change the color of the button from red to green, right? So I create a feature branch and I work on that feature branch exclusively until my feature is done, right? So you coordinate your work off of develop via feature branches. And then from there, those feature branches are long-lived. So they only get merged back into develop when they're complete. Release branches, once that's merged back into develop, you create a release branch. And that release branch can be a single feature, it can be multiple features, it can be a bunch of different things. So inside of that release branch is the source code that you are going to release to production. This sounds complicated, But once you get into it and you start practicing it, it really becomes second nature, right? Every bit of work that you're going to be doing, you do on a feature branch. Once that feature branch is complete, you merge it back to develop. And when your release manager is ready, he creates a release from develop. And like I said, that could be after each feature is merged, that could be after everything is done and you're ready to release. And then that release goes through its life cycle and then gets released to production. Once it's released to production, it's merged into main and or merged back into develop if any bug fixes or anything like that were put into the release. This is a good methodology for larger teams that are working on multiple features at a given time. This is a pretty good methodology if you have a large team and you have n number of features that are coming out at any given time, and you want everyone to be able to work on them in parallel and not have to worry about stomping on each other, not have to worry about messing up each other's feature. So each one of these features can be done and tested and created in isolation and then merged back into develop when they're ready. This is really good if you have a set release calendar. So if you say, okay, every third Saturday of the month, I'm releasing something, be it bug fixes or features or whatever. So when you have a set release calendar and you're sticking to that agile calendar, then this is a very good methodology for you. And this is what you see a lot of teams doing. I would argue that a lot of teams that are doing mainframe development today, this is an easier methodology for you to get your mind around because it's actually similar to your release cadence that you're doing today, even if you're practicing some form of Watergile or however you're releasing. Like I said, it's good for release calendars and sticking to that agile calendar, but it can be complex and requires training. The con on GitFlow is it does require a lot of training and there are a lot of merge points. So there are times when you have to merge that feature back into develop and you have quite a bit of merging to do back into the main development branch. So this can, depending on the size and scope of the feature, this can take some time to actually merge those changes back into develop and have them set. So it is complex and it does require some training. But at the end of the day, once it gets going, it actually flows really well. And for my 2 cents, I believe that this will be more analogous to how mainframers are used to working today than not. But that's an opinion statement, than more of an argument. So let's go ahead and move on to the next. GitHub Flow. So this was created by and practiced at GitHub. So GitHub created GitHub Flow for their internal development using, drum roll please, GitHub. And basically, it's a simpler way of handling the same feature branching that you just saw inside of GitFlow, right? But instead of having 2 permanent branches, you just do everything off of main. You do everything off of your main branch. You create your feature branches off of the main branches. They still go until they're complete and they're ready to, in their production ready to be merged back, and then they get merged back into main. But it eliminates the extra step. It eliminates that extra step of going. There are no release branches in GitHub Flow. So once you create that feature branch and that feature branch is ready to go, you merge it back into main and then you deploy main. You build and deploy off of your main branch into your production lifecycle. So everything, again, this is a good methodology. Well, let me back up one step. When you're done with your feature branch, when it means done, that means it has to be production ready, right? Unlike GitHub Flow to a certain degree without a release branch where you can make changes. Once you're set and that feature branch is ready to go and it's merged back into main, at that point, it needs to be production deployable, right? So even if you have a production lifecycle like a pre-prod, You're still not wanting to make changes or take things back from main and have to do bug fixes. So you need to be very disciplined in how you finish off your feature branches and make sure that they're ready to go. Like GitHub, or excuse me, like GitFlow, it's a good methodology for larger teams because again, you are creating those feature branches, working on them in isolation so you can have multiple things going on at the same time, and then you're merging them into main. It does require very rigorous automated testing. If you're going to make this work and you're going to make this efficient, you have to have a very good automated testing suite, especially to make sure that if I merge something into main and then it's going to be deployed into production, that I'm not breaking anything. Now, that seems like a Captain Obvious kind of statement. Of course, I need good production of course, I need good testing if I'm going to deploy to production. But that is especially true here because you need to make sure that that feature branch is ready to go before you merge it in. Otherwise, you've wasted a lot of time and energy, and you have to take it back to step zero, either create another feature branch to fix whatever problems or changes you have or not. So you need to have a very mature DevOps model to practice this on your feature branch levels and have a lot of really good testing. So this is not a methodology that I would, again, I think that this is a valid methodology to pick, and I think that this is a good way to do it, especially if you have a really good testing capability. If you don't, then I think maybe something along the lines of GitFlow might work better for you because it has that extra step of creating that release branch, which allows you to fix up any bugs or changes that are going in before you go to production. That said, again, this is a valid methodology. And I know a lot of teams and a lot of organizations that practice it because it's simpler and less back and forth than the GitFlow model. And like I said, coming straight from the source of GitHub, this is how they handle all of their internal development. So GitHub flow methodology, that's how that works. Well, the last one is trunk-based, right? Trunk-based development. So trunk-based development sounds exactly like what it is. There is only a single branch, and that is your trunk. Everything is handled by that single core. You could call it trunk, you can call it main, you can call it master, whatever terminology you use, but everything is basically handled and built off of that single branch, right? When you do create feature branches, quote unquote, they are very small and short-lived. The practice here is that I'm going to create a quick feature branch to create my code. And even then, when I say feature branch, it doesn't have to be a full branching. You can literally check down trunk, check out the code that you want, and then check that back in. But there needs to be frequent merges. And the point of it is to make very small iterative changes and check everything in daily. Now, that's when you read about trunk-based, that's what it will say, right? Whether you need to check everything in daily or not, the point of this is to make less of a merge problem, right? If I have a feature branch and that feature branch is very short-lived, then I'm not having to merge massive changes all at one time. Every day, everybody sees the iterative piece that I have done because I've merged it back into trunk. You can use releases or release branches, but typically people release directly from trunk, right? This is a good methodology for smaller teams that are very good at collaborating with each other and very mature, because it is very, very easy to break someone using trunk-based methodology. You have to be very mature and understand what you're checking out, what you're checking in, and how it affects the whole, right? It requires, just like GitHub flow, it requires a level of maturity and a high degree of automated testing, especially on the trunk. Because as I check changes in, they're very quickly could easily go to production because I'm constantly checking things in and out, right? Like I said, trunk-based development is a very good way to handle, like if you're a very mature agile team and you're good at, almost daily releases and daily updates to your code base, then this is a very good methodology for you. And this is what a lot of teams use. This is what a lot of teams practice today, because like I said, it's very easy. You're just really getting things in and out. But like I said, the con on it is you have to be very mature and you have to understand what you're doing to make this work, because the ease of use is there, but the ease of use is there to get bad things into production if you don't watch out. So trunk-based development, like I said, depending on what blog you read, they probably think that, depending on between this and GitFlow, these are the two most popular. Are there other methodologies? Yes, but these are the ones that are the most popular. So the natural question to ask after all that is, number one, which one is right? What's the right methodology? Right? And it depends on a lot of factors. There is no right methodology and there is no wrong methodology. Like I explained, for each one, there are pros and cons. For each one, there are trade-offs to what you get versus the benefits you get versus the problems you may have, right? Again, this is a question without a definitive answer. And if you ask 5 people, you're going to get seven opinions, right? A lot of organizations also do not practice these down to the letter, right? They customize how they handle Git and how they handle their merging and branching and tagging to fit their needs more specifically, in the same way that most agile teams, right? You have agile teams that follow agile down to the letter. And then you have teams that follow agile and they take the parts of it that work best for them and they don't use the parts that don't. And you see a lot of that with Git. A lot of organizations don't practice this. What you need to do is pick a methodology that fits your needs, or pick parts of each methodology that fit your needs. And then from there, decide what you want, right? It's really about what works for you. It's really about what pieces and parts and capabilities actually work for your teams and actually will work for you. You're not going to make a right choice or a wrong choice. And this could be the kind of thing where team by team, they practice this in a different way, right? You could have team A that's a large team with lots of different features that are going out in parallel, and they decide to use GitFlow. And team B is a small team that handles, smaller iterative changes, and they might use trunk-based, and that's fine. All of the Git clients from before support all these. Git itself supports all of these. It's just a way to handle the capabilities within Git versus getting hung up on, what's the right thing, what's the wrong thing, what does the book say, right? There is no book. Well, there is a book, but the book will tell you that there's a lot of different ways to handle this. Put it that way. So another question that comes up a lot that I see when I'm talking to organizations that are looking to move to Git: does the size and structure of your repo matter? So yes, it absolutely does matter. Okay. A lot of teams have spent decades smashing modules into a single mono repo, or even if you have them broken up by application, putting more and more and more code, more gigantic monolithic programs into their system in order to basically version and control their code, right? And that's the way a lot of the mainframe code has been done over the years. You can lift and shift that into Git, but you're not getting all the benefits of Git by doing this. moving to a source code manager like Git is a chance and a time to refactor how your repository works and how your repository is laid out. And there are ways that Git repository should be laid out. There's no one way because every application is a little different and the technology stack is a little bit different. But when we're talking about Git, right, most Git systems defined a 2 GB best practice for their repos. When I say that, that doesn't mean that if you go 2.0001 gigabytes on your repo, it's not going to work. It will work. It'll continue to work the way it works. But as you add more and more and more size to your repository, then at that point, you get, it starts to slow down, right? You start having to tune your Git client more and more, and you're going to find that then your operations are going to take a lot longer, right? And even if you have a repository that natively is 2 GB or less than 2 GB just from the source code, as you branch and branch and branch and branch, you need to clean those up, right? You can't just leave branches on top of branches on top of branches, because that begins to bloat the repository and your projects within Git, right? Too big and too cumbersome, and you have performance issues, right? That said, it's a good chance when you do move to something like Git, it's a really good chance to reorganize and clean up all of your source. It's a good chance to reorganize and clean up how you're storing your source code and how you have it laid out, right? So can you lift and shift? Absolutely. But then you're not going to be getting the benefits of everything that Git has to offer and some of the slick capabilities. And this is also going back to something I said earlier. This is why you don't want to put binary objects in your Git repository, because they take up a ton of space, and versioning those is not what Git was designed for. So one of the other big questions that I get asked a lot when talking about Git and talking about moving to a Git native development or moving my source code into Git is, most mainframe systems, you're used to being able to check out a single module, check out a single thing, a single capability. Whereas with Git, you're pulling down the entire repository each and every time you clone it, or each and every time that you get it, right? Basically, Git is a distributed version control system, right? So each copy that you make is a full copy of the repository. Each developer's workspace is a full copy, right? And this is sometimes hard for a lot of mainframers to get their mind around. You have to pull the whole thing down. Now, every time you do something, are you pulling the whole thing down? No. You're typically only pulling down the delta. This is a one-time thing and a one-time operation, right? But each and every copy on your local workstation is a full copy of the Git repo, right? And each developer's workspace, that basically allows you now to distribute the versions of your source code out to different local environments, right? So if something crazy were to happen, and no, I'm not saying that Git fails or falls down or whatever, but if something were to happen, you're not ever really going to ever lose your source code because everybody has a copy of it, right? So few questions that come up when I talk about this. So does this mean that changes are stored all over and there is no central place for all changes? No. Git has a central repository that when I check something out and then I create a feature branch and then I merge that back in, everything gets merged back into the central repository, right? And when I do those merges or those pull requests, right, that's only the delta of things that I've worked on that get merged back in. So Git absolutely has a central repository of everything that is stored. The only things that wouldn't be stored there are things that you haven't checked that committed, right? So each time I check out and check in, I am moving the full repository. No, you're only checking in and checking out those things that you want to work on, right? You're only checking out those files, those modules, those things that you want to make a change to and create a version of. And when I do that in and out, I'm only doing the delta. Won't that cause performance and resource issues having all that data on my system all of the time? No. Git, like I said before, is built to be very, very efficient in the way it uses memory and the way it uses storage space. So no, it's not going to have any performance issues on your local system unless you have an incredibly underpowered laptop or your repository is a ridiculous size. And I've seen 20 and 30 gig repos that while they didn't perform as well as they could, were able to handle up and down check-ins and checkouts. So it will not cause any performance issues, or at least to my mind, won't cause any performance issues as you use it. From there, that's my layout of Git and Git native development and Git native development on the mainframe. I'm going to go ahead and open it up for any questions, or if we have any questions in the chat. I'm not seeing anything in the chat, but I'm open now. If anyone has any questions or thoughts or just wants to tell me I'm wrong, I'm okay with that too. So.
Hi, Tony.
Hey, Stuart.
Just checking the chat. I hadn't seen anything. No, that's there's nothing in the chat at the moment. I think some of the stuff you've covered is interesting, because I've gone into organizations that have wanted me to implement a Git integration with the mainframe. And the first question I say to them is, what's your branching strategy? And it's always a bit of a tumbleweed moment, you know, that there's only a couple of very clear answers that come back. Sometimes it's not always been obvious around the branching strategy. So thanks for covering some of those examples. And then, of course, everyone in the mainframe has typically got some kind of monolithic repo stashed somewhere in an Endeavor system, or a ISPW application, or a ChangeMan equivalent. So breaking it down, doing a little bit of work there is important. And you mentioned some of the boundaries that can't be crossed, around repositories. I'm not sure if you covered it around interdependencies. How people use tools to work out interdependencies. I know there are products on the market for mainframe things like ADDI, or whatever the modern name for it is, and then there's another one from Beta Systems. But is there something when you're using Git that can identify those challenges where a repo contains maybe a copybook, and then a program uses a copybook from a different repo?
So there probably is something. I will say Git natively, and you're talking like GitHub, GitLab, or Bitbucket, they don't have anything built in to map out those interdependencies. And that's even true on the distributed side. If I'm pulling in open source libraries or capabilities like that, that's something I need to define in my config files, or in my Maven script, to pull those from a different repo and build them in. Now, it can handle if I have copybooks in a central place, or pull in copybooks from other repositories, things like that. It can handle all those interdependencies, but it's not going to map out application A and pulling this copybook from application B. That'll be something you'll have to define in your build, or use a tool like ADDI, or code assistant, or program assistance from BMC, or the ChangeMan equivalent, or to your point, Beta Systems has a tool. There's a lot of different tools to do that.
Okay, great. So yeah, I think it's a good grounding, because there's a lot of talk in the market around using Git as the version control solution of choice, but it's not as simple as migrating your source out of current version control into Git.
Yeah,
So
no, go ahead, Stuart. Sorry.
I was just going to say there are a few other people on the call. If you've got any questions, either type them in the chat or identify yourself, and I can unmute you if you want to talk directly to Tony at this time.
It sounds so intimidating talking directly to me, but yeah.
Well, rather than doing it through through the chat,
while we're waiting on that, or if anybody has a question, feel free. But I think you brought up something really well. I mean, if you think about, right, all of the, like when we're talking about the different methodologies and how you do, this is like a measure twice and cut once kind of thing, right? It is a very sort of planning this out and how you're going to handle this will lead to a lot of will lead to a lot less sweat later down the line, a lot less work and toil, because you've defined how everything's going to be organized and how everything is done. Then that, again, it eliminates all that thought process. Because I've had the same thing as you, Stuart. I've gone into companies and they talk about, moving to Git, how do we integrate Git? And one of the first questions I ask them is, okay, how are you going to handle your branching strategy? Well, I don't know. Most of them don't even understand what I mean when I say, how are you handling your branching strategy? So it's definitely, if you're going to make this move, it's worth the time and effort to think through it. Any questions?
There don't appear to be any questions at the moment. No hands up either. So I guess you've done a great job, Tony, in covering
the world
off
of Git has been illuminated. Yeah.
Yeah. And I know that the one company in the UK, a retail bank that had gone down this route, they definitely fully adopted the trunk-based development. It was important for them to have short-lived branches so that there was no merge hell from a mainframe perspective. Parallel development from the mainframe has been a desire and a way to create problems for many years. So trunk-based development was the future as far as that organization was concerned. So it's good that you've covered both the most extreme and the most sympathetic forms of parallel development. Brilliant.
Yeah, and again, it's about what works for you, right? If trunk-based development works for you, and that's how you then it works. There's nothing wrong with it. You just have to go in eyes wide open as far as that goes. I guess since there's no questions, I'll get the last thing, which is the session feedback. I don't know if you're supposed to introduce this or I am, Stuart, but I
go for it. You're on it.
Thank you. I thrive on feedback. So Stuart will tell you, knowing me personally, that I love to hear the good, the bad, and the ugly, and happy to get that feedback so I can improve these kind of sessions later on. So the session code is 4L, and there's the QR code down on the bottom left. If you want to submit, please submit feedback, because if I want to make these better in the future, I would love to hear what you liked and what you didn't like. I'd almost like to hear what you didn't like more than what you liked, but I do thrive on praise, so I'll leave it at that.
And my feedback is maybe there'll be someone in November that you can bring to the GSE event, in the in-person event, that can talk about their journey through the Git for the mainframe. I think that's the next step. We want to hear from a couple of organizations that have been through the transformation. That would be fantastic, from my opinion.
Yeah, no, I that's absolutely something in the works, and yeah, I would love to sit down with some people at the live event and have them talk through how, like, what they've done and how they've done it, sort of lessons learned.
Great.
Awesome.
Okay. Thanks, everyone.
Goodbye. Cheers, as they like to say in England, since I know a lot of you are in the UK.
Thanks, Tony. Bye for now. Ta-da.